Welcome! The Sun just produced two large flares. These are the first major flares since September of 2017. What makes them even more interesting, they are associated with a sunspot region that is from solar cycle 25. That's the new solar cycle. So this heralds the beginning of major activity from solar cycle 25. This video will show movies of these flares at different wavelengths and different temperatures. I hope you will enjoy. We judge the intensity of a solar flare from its X-ray signal. There are 5 categories that are generally recognized. That's A, which is the smallest, then B, then C, M and X. Each one is 10 times larger than the last. As you can see, a couple of days ago we had 2 M flares. We also had a C flare. So what we're going to do now is take a look at those individual events and see what they look like. Thanks to the Solar Dynamics Observatory, we have a lot of data to look at to see what was going on with these events. Particularly the Atmospheric Imaging Assembly, which my group helped to build some years ago, has 7 channels that range in temperature coverage from 50,000 degrees up to about 10 million degrees. We'll start with the lowest temperature line, that's the helium-2 304 line with a temperature of about 50,000 degrees. And the format of all these movies are going to be very similar. One day is going to cover about 30 seconds, so it's very much speeded up. And I've got a reference here for scale, which is the size of the Earth, inserted into the picture. What you're looking for in the helium-304 line is generally ejecta, and you can see a jet coming out from the southern part of this region in this particular slide. So let's take a look at what goes on at 50,000 degrees, which is the lower part of the solar atmosphere. The next movie is going to be the Iron 9 movie. That's about 630,000 degrees Kelvin. So this is not quite the high temperature corona, it's sort of in between. And so what you're looking at are the coolest loops in the corona. Now these loops are indicative of the solar magnetic field. And this is the loops that are populated with the lower temperature coronal material. Notice how the loops reconfigure after each flare. In fact, you can almost see a shock run through the region after each flare occurs. The next movie we will look at is the Iron 12 movie, and that's equivalent to about 1.2 million degrees Kelvin. So this is the high temperature corona, and you'll see that the loops look somewhat different because the material here is much hotter. The region is also more intense. Our next movie is an Iron 14 movie, which is characteristic by about 2 million degrees Kelvin. Now we're beginning to look at the much higher temperature corona plasma, which will be more associated with the flares. So you should see a bigger contrast when flares occur in this movie. Notice the dark jet in the southeast corner of this region, which is equivalent to the bright jet that we saw in the helium-304. Iron 18 is our first truly flare movie channel, and you won't see very much emission in this channel unless there is some sort of flaring activity going on. The last AIA channel we're going to take a look at is the iron 20 channel. That's about 10 million degrees. Now, one thing you'll notice, even at this relatively quiet time, you'll see a number of high loops which look remarkably similar to some of the earlier images from the active regions. This is because this iron 20 line is contaminated with other much cooler lines. So you'll get to see both the cool material and also the flare material. Now we're going to look at a completely different instrument. This is the SOHO LASCO movie, which is a coronagraph. Now, the normal size of the sun is shown in the middle of this picture, and the dark area around is what's called the occulting disk, which cuts out all the bright light from the sun. Now we're looking at scattered light off of the dust and gas in the outer corona. And what we're looking for here, particularly off the left-hand side of the image, is ejections of material. Remember, in the helium-304 line, we saw quite a few ejections, and so we would expect to see something in these. There was a faint one, and another, and a third. And that was probably that dark jet we saw earlier. Now, we first saw this region come over the east limb of the sun, but we don't know how long it was active before it did so. To find that out, we can go to the Stereo A spacecraft and look at a movie in some of the equivalent lines that we have from the Solar Dynamics Observatory. So this is a movie starting about 3 or 4 days before the region came over the limb. Stereo A is off the east limb of the sun at the moment, so the current limb that we see is down about the middle of this picture. Let's see how this region developed over the previous few days. We can see that even in this channel, the region appears on the limb of the sun still partly developed, so the region is much longer lived than just the video shows. So what conclusions can we draw from all of this? Well, first of all, this background graph shows the evolution of solar cycle 24 and the beginnings of solar cycle 25. So we are currently right at the far right hand side of this, and just showing the first upticks of solar cycle 25. The question is, which of the two models is it going to follow? It looks as though it's going to follow the lower of the two, but we have yet to see what will actually happen. From the data we've seen today from these flares, these are the first major flares from solar cycle 25. The flares were probably much larger than we observed because they were slightly behind the east limb of the sun, so the major part of the flares were actually obscured, so they were probably significantly larger than what we registered, i.e. more than an M1 flare. The region was active for several days before appearing on the visible disk. It has since then decayed somewhat since it rotated onto this disk, just our luck. We can expect more of the same in the coming months. We will expect to see more intense flares and more frequent flares as the years progress towards solar maximum. It should be an interesting ride. I hope you'll join me on it. Until next time, goodbye.